Today, our topic of discussion is radio carbon dating or carbon dating is undone. Okay, so basically, radioactive substance decay at a rate that we can determine, and we can use them to discover how old object and materials are. So we're gonna discuss this thing in very detail, how actually it works. So half-life and the radiocarbon dating. So what this half-life is, all the radioactive substance have a half-life depending on like which elements isotope it is. For example, if we take the isotope of carbon atomic number 6 and the mass number is 12. It has another isotope, its atomic number is 6 but mass number is 14. So isotope is a substance having same atomic number but different mass number, like here 12 and here 14. So out of these two isotopes, this is abundantly found and it is not a radioactive substance, but this one is a radioactive. So while using or doing the carbon dating, so we're gonna use this isotope of carbon 14. Okay, so how the carbon comes into this ecosystem? Plants get this carbon through the process of photosynthesis that all of us know. It consumes carbon dioxide, and in which the carbon is there, and this plant get eaten by the herbivorous, okay, plant eating animals. So this carbon get transferred to this herbivorous. Now some of the animals are herbivorous eaters that are known as carnivorous or omnivorous. Omnivorous can be eating plant also. So anyway, it will be getting this carbon also. So most carbon that they are getting is this carbon 12. Okay, and obviously I told you earlier it is a non-radioactive part of carbon, and a tiny fraction of this radioactive carbon, that is carbon 14 isotope. Okay, its half-life, if we look into approximately 5,000 years, to be precise it is 5370 5370 years. So this is the half-life of this carbon 14, means after this year. Okay, so if the weightage is like 100% of this carbon 14, so after this 5370 years, its weightage will be like 50%. Then again after this one more, then it will be 25, and then again 12.5. Like this it keeps on decreasing. Okay, so while carbon dating, if the scientists come to know like the remaining carbon 14 isotope percentages in this form, so it means how many time? One time, two time and three time. So approximately 15,000 years approx, that stuff is 15,000 years old. Okay, so by this we can come to know this old this animal or the plant is. Okay, so idea behind this radiocarbon dating is this only: when the living organism die, the carbon 14 in its body decays. As the time passes, the amount remaining keeps on decreasing. We can measure the amount remaining, so we can come to know how old that stuff is. Okay, so now comes how we can do that. So there is the two method of it. One, by measuring the activity of the sample using a detector. That detector is invented by Geyser, so it's named as a Geyser counter. And another method is by counting the number of carbon 14 atoms, means this, by counting this thing using a mass spectrometer. So it is a spectrometer. It is a mass spectrometer instrument that help you to measure this carbon 14 isotope. Okay. Now, even in this, there is a problem. So anyway, you come to know, okay, this 15,000 years old this fossils is, but there can be a problem. You can't be precise because it may be that the amount of carbon 14 present in the atmosphere was different in the past. Certainly, nuclear weapons testing has been done. Normally, it has been done at the time of 1950, 1960, and even after that. So, that fossils might got the weightage of this carbon 14 radioactive isotope in itself. So, even though it will be older, the fossil will be older, but it will be showing you like it's recently sort of. So there can be some differences in this calculation. So this is one of the drawback, you can say, the radio dating. Now move on to the what other uses radioactive dating techniques, what other use we can have. So we can also find the age of rocks, how old the rocks are. So geologists and the scientists who just work with the rocks and all, how old the rock is, so they are known as geologists, uses radioactive dating techniques to find the age of some rocks. Many rocks contain the radioactive isotopes of potassium 14. So its mass number will be 40 and the atomic number is 19. Okay. So this potassium isotope and which do the beta decay. Okay. It will be doing the beta decay, beta particle. Same thing is happening with the carbon 14 also. It's also decays the beta only. So beta decay is happening and it get converted into argon. So its atomic number is 18 and as you know it is a noble gas, so a stable configuration it will have. Okay, so in this case again this thing getting reduced to 18 stable form by the decay of this beta decay. Okay, so argon is a gas and it is trapped in the rock as a potassium decay, and here is how the dating system works. So the rocks of interest that we want to do the observation form from the molten material. All of you have done in the geography that volcanic eruption happens, then molten lava comes out. So the rocks what we are analyzing will be a part of that volcanic eruption. So there is no argon in the molten rock because it can bubble out because in the gaseous form. So that molten rocks won't have the argon. After the rock solidifies, amount of trapped argon gradually increases as the potassium in the rocks is now decaying. Okay, so we can say by knowing the value of argon, we can come to know how old that rock is. Greater the proportion of argon, older the rock will be. So more the percentage of argon we're gonna get into the rock that will be trapped in the gaseous form, more old that rock is. So this is another use of radio dating technique. Okay, I think you got the basic idea about how this radio carbon dating works. Thanks.